network or a subnet. First, we're going to discuss about. We are already discussed about a network portion and host portion. Then here also we'll discuss like this. Guys, remember network bits meaning is ones. Okay, host bits meaning is zeros. The subnet mask or a host portion. Okay, so this is I will tell what it is, but before going to this thing, this networking related kind of stuff. So why I'm confusing? Why I'm telling something? Yeah, number of hosts per network. So here it is, one network, three hosts, right? One network, three hosts. So here from class C, I'm going to calculate. Then we'll see. Number of hosts are network. Sorry. So yeah, mind no, not connecting. So this is the network portion. This is the host portion. So one single host portion means one octet is host portion. Last octet is host portion. Octet means how many bits?
Yeah, 8 bits.
Octet means how many bits? 8 bits. Right? Very good. Next. Okay. Next. In each network, there is a network ID and broadcast ID is there. So how much big network it is? Either it is class A or class B or class C. There is a one network ID and there is a broadcast ID. In between network and ID and broadcast ID, all are host IDs only. So out of total, two are we are not assigning to anyone. Okay, these addresses we use it but not assigning to host. We don't assign these IP addresses to any of the host. So that is -2. Okay, so the equivalent value is 256. Sorry, 256 minus 2 is 250, 254. Number of hosts per a network. It means in a class C network, meaning is in a class C network, you can, if you take a class C IP address, if you take a class C IP address, 254 number of PCs or devices you can connect. So I will write in a line. So about this one, see, you can see class C. So totally 254 number of hosts per network or a subnet. So some people write a subnet, but I'm writing per network here. Okay. You can write subnet, so don't get confused with any other sentences. Okay. So 254 number of hosts per subnet. It means if you take a class C IP address or a IP network. Okay, so we can or you can connect 254 number of devices. You can connect 254 number of devices. Okay, in a single network. So 254 devices you can connect. So the sentence can be interchangeable. Okay, if you take a network, it means so totally 254 IP addresses you are getting. Meaning is totally 254 IP addresses we are getting. Okay, so 254 number of devices or a host we can able to connect. Okay, like that. Same goes here. Here is number of host portions are 2. Means each host is 8 bit. Now, how many bits are there now? 8 plus 8?
16.
16, very good. Minus 2 because of network ID and host ID. So, again, we have to go to calc. So, 2 to the power of 16, right? So, we done mistake. So, 2 to the power of 16 is 65,536 minus 2. 65,534. Okay. So 65,536 minus 2, 65,534. Number of hosts per network. Means if you are using a class B network, you can connect more than 65 computers together in a single logical network. Okay. In a single logical network, you can connect with. Okay, it's a single network. Okay, totally like a different names, different way of explanations are there. So which statement is easy to understand, that statement take it. Okay, so in a class B, if you are using, it means you get a 265,534 host IP addresses you are getting. It means you can connect more than 65,000 devices. You can connect it. Connect it means like we are getting that many IP address in a single logical network. Now, class A, 3 host versions. 3 host versions. 8 plus 8 plus 8. How much?
24.
24.
24. So here it is 2 to the power of 24. This is 16,000. 16,777,216. This many things, like a 16 million devices we can able to connect it, and there is a -2. So compulsory you have to do -2. So why are doing -2? Because of network ID and host ID we are not assigning to any host. Sorry, network ID and broadcast ID we are not assigning to any user. So any device or any user. So we have to minus that one. These are a host, number of hosts per network. This is total IP addresses. This is number of hosts per network. So you can connect 16 million IP addresses. You can able to connect it. 1 crore 67,000 you will get it. So guys, here it is one example. Here it is. I have a network. For example, I have a small network is there in my office. Okay. So in my network, so I have a 50 computers are there. Now you are administrator and I have a 50 computers. I am asking, can you tell me which IP address, which class of IP address is better? Which class of IP address is better? Anyone guess?
Class A.
Class C. Because 254 is a maximum size. So better than class B and all. You are not wasting more IP addresses. So how much you are wasting also we'll see. You take class C, it means 254 IP addresses and 50 IP addresses you are using. So totally wastage is 204 only. But if you take a class B, what will happen? If you take class B, 65,534 IP addresses and your devices are 50 only. So almost 65,000 IP addresses are not utilizing. So not required in a private or public. If you are using a private IP address or public IP addresses, it is whatever it is not required that much of big network. So based on your network, you have to plan which class of IP address you can take it. That is one kind of plan. That is, I have another network. There is a 150 devices are there. Now tell me. Which class is better?
Class.
150 devices.
Class C.
Class
Class C only.
Yes.
Class C only because it's 254. Okay. Now I will change it. Now I have a 300.
We
Class
can
B.
go Class B.
Compulsory, no choice. You should go to Class B only because Class C is 254. So you cannot connect 300 devices in the single network. So you have to choose the IP address from Class B only, even though there is a wastage. Another network is, now I have a 3000 devices are there. 3000 devices are there. Which class is better?
Class B.
Class B only because 65,000 up to 65,000, no need to worry. Okay, so if it is more than 65,000, like a 70,000, okay, or 66,000, 70,000, or 80,000, 1 lakh computers are there, 1 lakh devices are there, then only better to go for Class A. Okay, so this is the why we divide devices, your IP address into classes. This is one of the reason. So you can choose the type of class based on the network size. This is your network size. Okay. So we know how to divide the. We can understand which class, which is network portion, which is host portion. But how system will calculate based on the default subnet mask and based on the change of subnet mask also what will happen. So these things we'll see little bit. Okay, here it is, AND gate. AND gate, there is a logical gates are there, OR gate, AND gate, NOT gate, XOR gate, okay, NAND gate, XNOR gate, NOR gate, NAND gate, NOR gate, XOR gate, XNOR gate. These are the logical gates. And if anybody, sir, we are from the mechanical background or any other some non-IT background people, don't worry guys, it is there in your 10th class mathematics only. Okay, the gates are in a 10th class mathematics only. True, true, false, false, true, false, 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 like that the kind of stuff is there now. So that is nothing but this one only. Okay, it's a logical gates. Okay, logical gate are logical statements. Okay, CPU, central processing unit. Okay, ALU, arithmetic and logical unit. Arithmetic and logical. Arithmetic means plus or minus kind of stuff. Logical means and or, not nor, NAND, XOR kind of stuff only. So system will calculate based on that one. Okay, so whatsoever it may be, it is simple a logical expression. So A is the input, B is input, A is input, B is the input, and Y is an output. The expression for this one AND gate is A dot B. Okay, expression for this one is A dot B. Zero. So input is 0 and another input. There is a 2 inputs. The expression is like this. Okay. So one input is 0, another input is 0. 0, 0 is output is 0. If one input is 0, another input is 1, the output is also 0 only. If one is first input is 1 and the second input is 0, the output is 0 only. If first input is 1 and second input is 1 and output is 1. The meaning of AND gate is if both inputs are high, output is high. Okay, both input is high, output is high. Or in a truth table, as per the, this is a truth table. So as per the truth table, if both inputs are true, then output is true. If any output is, sorry, any input is false, output is false. Any one of the any of the input is false, output is false. Okay, both are true, then it is true. Okay, if both inputs are high, output is high. If any of the input is low, output is low. So that is called a AND gate expression. So how to do it, guys? Look at here. So I put a values. Okay, like this. You can see 1 0 1 1 1 1 1 0. For example, so this is my two values are there. How to calculate? First take 1 1. This one and this one. 1 1 is 1. This is 0. This is 1. So output is obviously 0. 1 1 output is 1. 1 0 output is 0. Okay, so this is your output. So this is how to calculate. If you want, see here it is 1 0. As per the table, 0 is there. It means definitely 0 you will get it. Both are 1 1. Yes, 1. This is 0. This is 1. This is 0. This is 1. This is 0 only because 0 is there. Both are 1. Output is 1 only. So like that you will get it. I'm taking like this. If you take, if all inputs are one of the input, it means one side of you got some data like a 1010 binary data is there, but in another set is all are zeros only. So you don't need to think anything, just 1 0 0 0 0 0 1 0 0 1 0 0. Obviously you'll get a zeros only. If in case, for example, you take an input and all in another input, all are ones only, all are ones only. Okay, all are ones only. You have an input, but that is having something 0 0 1 like that kind of stuff. But second input is all are ones. So here it is, same input will be repeats. You can see this is and this one is same. Why? Because of 1 1 1 0 1 0 1 1 1 1 1 1. So obviously wherever the ones in here, those ones will come up. Zeros are there, definitely 0 is there. So that is your NAND gate. So what is your NAND gate is simply say, so if both inputs are 1 1, then you will get 1. If any one input is 0, output is 0. If all are zeros in the second one or a first one or a second one or a first one, whatever it is. So if one set of input is all are zeros, you'll get a zeros only. Okay. If one set of input is all are ones, you'll get a same input data only. So no, like if you have a very big number, but big number is there, like 1 0 1 1 0. Like this, but you got a all are ones in the second input. So you need to calculate one by one. So how to do? Put the direct input here, because one side is, okay, this side is all are ones only. Whatever it is there, it will be come here. So no change in it. In another hand, so I will control. Even though you take this much of big input and all are zeros here in the when you are calculating, all are zeros like this. This is the column you got it, and then when you calculate, no need to think, you got a output is all are zeros only. So this is how to calculate AND gate. Guys are okay? AND expression is okay or not?
Okay, sir.
Okay, sir.
Yes, sir.
So look at here. I'm taking some IP address. So any IP address you can take it.
Sir, once repeat.
Yeah, tell me.
Once repeat, sir.
Okay, you want to repeat? Okay. So otherwise, take a new column, then you can try. Anything. So this is a input, 8-bit input, 8-bit input. Now tell me output from starting from this side or this side, anything, no problem, but better is this side because computer na we have to type 1 1
1
0 1
0 0
1
0
0.
1 0 0.
1 0 0.
So like this, you'll get it. Okay. The question is, I take this set. I think people can easily understand this part. This is very easy. That's a little confused. Calculate.
Zeros.
Okay, very simple. Like you not to do anything. Just you see all are zeros means 1 or 0, whatever the upper portion, 1 or a 0 in the this portion. But if 0 0 is always a 0 or 1 0 is also a 0 only. So no need to think. So you can put a simply zeros here like this. Make sure all are zeros. If all are ones, sorry, I will take this one. This is my one input. All are ones. All are ones. Maybe in
1
all
1
zeros
0
are no problem, but it is same 1 1 1 1 1 0 1 0 1 1 1 only. Again 1 1 0 1 0 1 1 1. So if you look at this one, this is and both are same. Okay, both are same. Okay, so like this. So make sure that it's it is quite easy. So no need to. So there is a binary conversion is also there. So I will tell a very simple manner. I will take already cannot kind of stuff. Okay, so here it is. I will take one example from here. So class. So like this. This is the IP address. I took an IP address. I will take in one IP address, and I will try to find it. What is the subnet? Sorry, what is the network ID? What is the network ID of it? Okay. So which class it is? Class
Class B.
Class B. Why it is ringing? Why it is making noise?
Sorry.
1 second, wait, like I got maybe I'm an organizer, right? So who can able to mute me? Nothing is received. Okay. So this is class. Okay, class B subnet mask. Okay, so this is the class B IP address. So I took it class B subnet mask. Now, how to calculate network ID? You have to convert your IP address into subnet mask, and this one is also into sorry. Mind from after 4 o'clock. Something has happened. Mind is not working. So I have to convert my IP address into binary, and this one is also into binary. So people who are new to the binary part, so I will tell how to convert into binary also. This is my 151. Convert into binary is very simple. Take 128, 64, 32, 16, 8, 4, 2, 1. So what is this? It is a binary direct conversion. Normally, people convert any number into binary is like this, 151. Like you have to keep dividing with a 2. So for example, this is 75 and there is a variation is 1. 2 into 75 is 150. So 151 1 minus 150 is 1. Okay. So like that, you have to keep this number aside. Next 2 and 174 means 35 is 70 74 3 no 3 yes okay 1 4 or 15 7 37 is 174, so minus like this, so 74. It is a hard number. And again 36, 37 cannot be divided, right? 36 means 18. 2 18s are 36, and this is 1 will be remainder. 2 9s are 18, then it is 0. 2 9s are 18, that is 0. 2 4s are 8. 2 4s are 8, so 1 will be remainder. 2 2s are 4, so like this is 0. 2 1s are 2, so then it is 0. Okay, so obviously you can write it from here. The final remainder always 1. Okay, or you can put a 0 here. 2 zeros are nothing, 0, so you will get a 1. So the output is the binary equivalent of 151 is 1 0 0 1 0 1 1 1 like this. You have to write from bottom to top. Okay, or top to bottom. So it depends upon how you write. Okay, so this is output. I got it currently. Okay, this is 151 traditional way of converting, but I use this formula to convert it. It is 128. Compare 128 with 151. Guys, if you don't understand this method, it's okay, no problem. Just but look at once. Okay, later practice. So here it is. 151 is bigger than 128. So then I put a 1 and a minus 128. Okay, so minus 128. So if you subtract it, so what you will get it is around 31. 8 means 20, 23. Okay, so 23. Okay, this is you get 23 here. If you subtract from here to here, it is 23. Okay, I think so. We'll see. So 23 compares to 64. 23 is a smaller, put a 0. 23 compared to 32. 23 is smaller, put a 0. 23 compared to 16. 23 comparing to 16. 23 is a bigger, put a 1. Hello. Hey, good evening. Who is this? ఎక్కడి నుంచి వద్దాను బాబు. Okay, sorry. Okay, so 23 is bigger than 16. I put a 1. So subtract 16 from it. 16. So if you subtract 16 means 13 minus 6. So it is a 7. So 7. We got a 7 here. Right. So 7 compared to 8 is 7 is smaller. So 8 is 0. 7 compared to 4. 7 compared to 4. 7 is bigger. So 7 minus 4. It is nothing but a 3. Okay. Now 3 compared to 2. 3 is bigger. 3 minus 2. 1. So 1 equal to 1 anyway. This is the binary equivalent of 151.
0, sir. 3 is bigger than 2 now.
Yeah, 3 is bigger than 2.
Okay.
Okay, you try like this. Like I will tell very simple way. Okay, same thing only. I'm typing here 151. Compare 151. Compare 128. 151 is big. This side only. So keep this side is big one or not. Okay. So big. It means put 1 and subtract. If you put a 1, do subtract. If it is 0, do nothing. So I got a 23 or something. I got it right. So 23. So now 23. Compare 23. Now compare 23 to 64. 23 small. 23 small. 0. Again 23 32. 23 small. 0. Compare 23 16. 23 is big. Smaller big. So 23 is bigger than 16. So minus 16 and put 1 here. Next. Subtract. You will get a 7. Now 7 compare with 8. 7 is bigger or not? Not big. Smaller. Small. 7 is small. Put 0. 7 compare with 4. 7 4. 7 is bigger. Very good. put a 4. You get 3. Okay, then put a 1 here. 3 is bigger than 2. 3 is bigger than 2. Then put a 1 here, put a 2 here. Okay, now 1. So 3 minus 2, we got a 1. The 1 compared to 1. Both are same, equal, put a 1. So this is a error output. Same goes for a 120 also. For first time only I am doing like this for you, just for demonstration purpose only. So whenever you see 120, okay, when you see 120 compare with the 128. So 120 is smaller. 120 is a smaller. Now 120 compared with the 64. 120 is big. When it is big, then only do 1 and as well as 64. Okay. So 16 means 56. The you got a 56 if you subtract it. Okay. Now 56 compared with 32. Again 32 is bigger. Again 32 is, sorry, 56 is bigger than 32. 56 is bigger than 32. Put a 1 for a 32 and minus 32. Again subtract. So now 26 minus 2. It is 26 minus 2, 24. So put a 24. Now compare again 24, 16. 24, 16. So 24 is bigger than 16. So he put 1 here, put a 16 here. Now it is 8, right? So 16 plus 8 is 24 actually. Okay. Now you got 8 here. So obviously for 8, you have to put a 1. Now 8 minus 8, you got obviously 0. Nothing to do it. All remaining are zeros only. 4, 2, 1. All are become zeros only. So this is the 120 equivalent. If you got a doubt, go to the calculator. Programmers. This is decimal number 120. So binary equivalent. So you can see 4 ones, 3 zeros. 4 ones, 3 zeros. Same goes here. It is 151. 1001 0111. Okay, like this you can able to convert it. So again I am writing this entirely here. 1001 011 is a 151 dot 0111 1000. This is 120. 10 I know, so 000. 10 means 00. Sorry, 1010 is a 10. 2 is like this. 2 is like this. So this is your IP address equivalent. 255 is quite easy. All are ones only. 255.255. Remaining are zeros. Okay. So now you should calculate from here. See 1 1 1 1 1 0 1 0 0 1
0
0 1 1
1
1
0
0 1 0 1 1 1 1 1 1 dot. 0 1
0.
0.
0 1 1 1 1 1 1 again 1 1 0 1 0 1 0 1 0 0 0 0 0 0 0 0 1 0 0 0 1 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 1 0 0. Okay. See, anyway, why I calculated just to show you only. But if you see, these are all one. These are whatever it is repeating here. It is repeating here. 255 means 8 ones. 255 conversion is 8 ones. Okay. And here it is also see all are zeros. You got all are zeros here. All are zeros. All are zeros only. So no need to do anything. So I have to convert this back to binary. So that's decimal number. It's nothing but 151. Already we know 120 0.0. Okay. See 8 zeros 0 8 zeros 0. This value is 120. This is 151. So this is called a network ID. This is the network ID of this page. This is the network ID. Guys, understand network ID calculation?
Yes.
Yes, sir.
Binary conversion may be headache for some people. If we are in a real class and we have a time kind of stuff, so definitely we can understand binary conversion. If you understand this method, so it is quite easy to convert any number into the binary number without pen and paper. Without pen and paper. The only thing is we must know the range. Okay, it is higher than 128, lower than 256. Lower
In
than
interview, how they will ask, sir, this type of questions?
they don't ask.
Okay.
Okay, they don't ask how to convert. Maybe usually they don't ask how to convert a binary number, but better once at least minimum knowledge. Make sure you have a minimum knowledge on it. Either this method or maybe in this method, you must know the minimum knowledge in it. So do not ignore anything.
This method
Point
only is easy,
what is
sir.
network ID? How you got a network ID? From subnet mask. Yeah, tell me.
Oh, this method only is very easy from the first method.
This method. Yes. Because we know, you know already this method, that's why it is quite easy. And this is a complete confusion in a part. But in a reality, like you have a very shorter time, you don't have a pen and paper. This is very easy. Okay, actually this is very easy. But you need a practice. The practice make better, easier way. Okay, we don't need any pen and paper for that. Okay, in mind only you can see and you can look at and this one. You know, when I learn these subnetting concepts, binary conversions and subnetting concepts, which is your network ID kind of stuff, which is your host ID, how many number of hosts. These are questions, common questions in any network administrator questions. So I took this website. Subnetting questions, not calculator. So we don't get any calculator in interviews. Okay, I'm not telling you about you. I'm talking about interviewers questions. In a networking related interview question, only pure networking base interviews and okay. So they'll ask a question like this. They put a IP address and maybe a subnet mask. Then ask what is the last valid host on the subnet mask? What is the last host on the subnet mask. This is they will ask this question. So you have to calculate immediately. So no other chances. Like you don't get a pen and paper. Even though you get a pen and paper, you will take a lot of time. Okay. So lesser the time, and not using much pen and paper also. By looking at, you have to tell the answer, that is. So by question it is last valid host on the sub network. It means they given already network ID. They given a network ID, and this is the 154. So 154 means only one is different. Okay, so it is like a answer is 170.26.185.254. Remember last two digits, 185.254. 185.254. By looking at, you can tell an answer. I took 2 months to practice. I go to this website, then put a one by one questions, keep practice, keep practice, keep practice. Then I make it very easy for me. For it is not that much easy now. It will take a lot of time to practice and get it. And no guideline, right? So only small 1 day class. I took a 1 day class, practice 2 months. Okay. Even my brother is also working in a TCS now. Okay. So he's also parallelly, we both together, he given actually this website. My brother given that website, and he said practice. Okay. So like that, so we become learners. Okay guys, whatever it is, this is how you can calculate a network ID. I will take one more IP address from any corner, so then I will take it like a class A or like this, anything. I will take this one. This is class A, right? Okay. Now calculate network ID. Only network ID I'm asking. So tell me subnet mask for this IP address. Anyone?
255.000.
That's it, right? So no, not much things are there. So as per my, I said a methodology, you have to convert entire thing into binary, and you have to convert this into binary. So if you convert it, then do the NANDing operation, then you will get a network ID. But as per our earlier experiences, look at this one. 255 means all are ones. Whatever the binary number of it, you do AND operation. You do AND operation with this one. It is like this. Okay. See, 100 is directly came. Why? Because of what are the 100 in a binary? What are the in a binary? But this side is 255. 255 means all are ones. If all are ones are there, whatever it is, same is repeating. So that's why I have written 100 directly. Next, 120. So usually this is 120. Okay, and these are all are ones. That's why it is repeated. If in case all are zeros, then
0.
0 means 8 zeros. No need to calculate. This is your network ID. Okay, so just depends upon your subnet mask. So you'll get a network ID very easily. If network ID, sorry, your subnet mask is different, then definitely there is a problem. Definitely there is a problem. Guys, so last point I will tell, and then I will
Sir,
give you.
how it is, sir?
Yeah, tell me.
Sir, how it is 100.0.0.0, sir?
100.0.0 by calculating it. So if you convert it into binary, so 100 into binary, 100 in binary. Okay. Next one is 120 in binary, 12 in binary, 134 in binary. Okay. So you are converted, for example. Okay, we are not converting here, so just for example, you connect it. Next one is 255 in binary, 0 in binary, 0 in binary, 0 in binary. Okay, 0 in binary, 0 in binary, all are zeros. What are the number? What are the value of this 137? Sorry, 134. If in case I put a 134 in binary here, all are zeros. What is the result? I convert 134 in binary, and second one is all are zeros. Now do AND operation. AND operation. All are zeros only, right? Same goes for this one. Same goes for this one. So what are the values this one? The second one is 0, means 8 zeros. Obviously, you'll get a zeros only. And coming to the first one, 255 means all are ones. What are the value is this one? Whatever it is. When you do ending operation with all ones, you get a same value, this value only you will get it.
Excuse me, sir.
Yeah, tell me.
To do the network ID, we should feed these values, no, sir? Like
Yeah, this is a
255.
subnet mask. Very good. This is the subnet mask. This is my
Okay.
IP address. Okay. So
Okay, sir.
very good, very good. Actually, you are communicating from one PC to another PC. When you are communicating from one PC to another PC, what is the rule? Rule. I said rule. One rule. The lot of rules are there.
Same network but different host ID.
Yes. There must be same network. Network portion must be same. Meaning is network ID must be same. Meaning is network ID must be same. Okay. So if both devices network ID is the same, then they will communicate each other. Important is if two PCs are there in the same network or not. How we know? By checking network ID. So to understand network ID, how system is understanding network ID. So like this only. Okay, by using ending operation. Very good question. Okay, network ID must be same. Then only two are the devices are in a same network, means their network ID must be same. Devices are in same network, means same logical network. Same logical network means network ID must be same for the devices. Devices must be same. Whether it is same or not, how we know? We'll see that one. Okay. I will take some class C kind of stuff. So like this. For easy to understand. Okay. Now tell me the network ID. Directly, no? So 255.
194, 220, 10, 0.
Very good. Now
ఏడున్నదా చేయమంటావా మీ అన్నకు
this is a one
చేయమంటావా మీ
network
అన్నకు
ID. You got it. Now I took a 144. Tell me again network ID.
194, 220,
Plus 0.
10, 0. Same.
Both are having same network ID. Okay, so this PC and this PC can communicate each other because of they're having same network ID. So we'll go to the more confusing part is a classic kind of stuff, right? 172, 16, 100, 18. Okay. 255, 255, 0. Now tell me 172.
16, 0, 0.
0
This is the network ID. 172, 16, 26, 91. Okay. Default subnet mask.
172
172, 16, 0, 0.
So maybe it is look like a different one, but it is same network only. Same network only. Okay.
yeah
So it goes like this. Okay. So
Yeah,
we can
understood, sir.
if both networks are same, then both will communicate each other. Yeah, tell me. Okay.
understood sir yeah
Understood? Okay. Very good.
yeah sir
I thought you are asking question. I ask one question. What if I change my subnet mask? I changed my subnet mask. Look at here. Actually, it should be 0, but I given 255 here. Network ID is
Changed.
100
sir.
only sir
here also 26.
26 only sir yes
So network ID is also
26
so obviously different network IDs. I changed my subnet mask and I got a different network ID. See how subnet mask influence on the network IDs. Okay, I changed my subnet mask and my network ID is changed. Now both are different networks. Now both are different networks. So that is okay. Understand the concept?
yeah sir
Yes, sir.
Yes, sir.
So subnet
Sir,
mask is
sir.
changed, network is changed. Yeah, tell me.
then about the binary numbers you can mention tomorrow
You want binary conversions?
Yeah.
Yeah. Okay. I will see. We'll end of the class or like that. We'll take another 10-15 minutes. You tell number and I will convert, or I will tell number. You will convert. Okay. It is not very important one currently.
yeah you can say tomorrow also sir no problem
No. Tomorrow again new topic, new things, na. Okay. So okay, no problem. So, okay, we'll see first of all. Guys, understand this concept. Network ID is changed because of I changed my subnet mask. Not only that one. There is a one more is there, that is in the size of the network is also different. Size of the network is also changed by subnet mask. Changed by my subnet mask. Okay. So I want to tell one point because before I forget this one. CIDR. This is called a classless domain routing. What is CIDR? Classless inter-domain routing or routing. The CIDR abbreviation, but it is a, what is this classless and classful? Remember guys, so when we use an IP address with a default subnet mask, IP address with the default subnet mask, okay, IP address with a default subnet mask is classful network. Classful network. What is classful? You have an IP address and use default subnet mask. It means class A, class B, class C subnet mask are there, like class C use 255.255.255.0. Class A 255.0.0.0. This is classful networks. These are a classful network. Okay. Next, what is classless? If you don't use default subnet mask, use some customized subnet mask, different subnet mask. If you are using different subnet mask, that is called a classless. IP address with a customized subnet mask, okay, it's called a classless. Classless or a classless network or a classless. IP address are a network with a default subnet mask. IP address are a network with a customized subnet. Means customized means some calculated some different subnet mask. Okay, that is. So what is this CIDR and what is the CIDR method? CIDR or a CIDR method is means represent subnet mask in slash notation. Slash. This is called a slash, right? Slash notation. Represent subnet mask in the slash notation. Guys, remember, I given some IP address, for example, 181.13.14.12. This is my IP address, which is class B, and I didn't given. I don't told, like I given this IP address to you. I don't tell what's its subnet mask. I didn't tell what is its subnet mask. So it is a classful network only. Default subnet mask only we are using. If you don't mention subnet mask while you are writing or you are telling an IP address, you are telling this IP address like a 181.13.14.12, and you didn't specify what subnet mask you are using. Meaning is you are using default subnet mask, means full classful network. Understand? You don't tell about a subnet mask. Meaning is you are using classful network only. Classful network only. Okay. So that is important. So classless network. It means if you are not using default subnet mask, compulsory mention the subnet mask. If you don't use default subnet mask, if you don't use default subnet mask, so mention subnet mask. Okay, must be mentioned subnet mask. Must mention subnet mask or compulsory mention the subnet mask. If you use default subnet mask, no need to mention subnet mask while you are writing or something. Okay, writing or sending or speaking. Okay, so that is while you are writing an IP address, so no need to mention this one. But while you are assigning, keep careful. Okay, this statement up to normal understanding purpose only, guys. So slash notation usually for classless network, instead of writing a full subnet mask, you can write in a slash notation. Guys, look at here. This is 255.0.0.0. If you convert into the binary, it is like this, right? 8 ones, 8 zeros, dot, again 8 zeros, dot, 8 zeros, dash 8. What is that meaning? Number of ones in the subnet mask is represented here like this. So you take 255, 0.0. It is class 16. Why? Because of 16 ones are there in this subnet mask. Class 24. Okay. And also the slash or a prefix is also say like a prefix. Prefix means prefix length in networking. In networking, a prefix length, subnet length. It meaning is very simple. You are representing a subnet mask, or you are telling about your network address or network IDs, network space, network size, like that. Okay. So like you're writing an IP address 192.168.10.11, and you are using a default subnet mask. No need to tell anything. But sometimes you have to specify /24, or you have to write your subnet mask like this. Okay. So that is just a representation. But of course, there is a few more kind of stuff is there, like not /24 is the highest one. Yeah. So example I will tell. First of all, I'll take this one. So this is the same only. Okay, that's it. That's it. Not saying anything. Say classless inter-domain routing. Classless means if you use classless means if you use customized subnet mask, means not default subnet mask, it is a classless network. Okay, if you use default subnet mask, is a classful network. Okay, if you write an IP address and you don't mention the subnet mask, means it's a classful network, default subnet mask. Okay, so if you are mentioning it, so if in case if you are using classless network, it means not default subnet mask. Compulsory you have to mention default subnet mask. Okay.
So
So
one
different type of
example of
subnet mask.
classless network.
Yeah, tell me.
So one example of classless network.
This is a classless network. Which class it is? Class B, but I use subnet. Okay, I will write something in a different way. Okay, so like this, 116 and that maybe I will put 100 slash 26. Okay, what is the meaning? 26 ones are there. 26 ones are there, like this, 111 111 dot 111 111. 24 ones are finished, right? 1100, like this. 26 ones slash 26 means this one. You convert into this subnet mask into decimal format. 255 255 255 192, like this only. This is 192 in binary. So this is your subnet mask. Guys, understand?
Okay.
Yes, sir.
Okay, so it is a class C. So suppose it should be like this, right? But it is not like that. It is like this because of customized one. So there is a lot of things are there. Normally, when you got doubt like a 255 is okay, but what about these values? So we know zeros. Everybody knows zeros. The value is 0. In subnet mask, always zeros follows from here. So that's a 128. This is binary equivalent is 192. Uh, 224, I think. Uh, 240. Sorry. Mistake. So 240. 248. You have to convert into decimal format. You will understand the values. 252, 254, 255. Okay. So this is the equivalent. So whenever you see, so from here you can understand from it. Okay. For example, you put a 172, 16, 17, 18, something, and I put a 20. What is the meaning of 20? So first 255, 255. So how much it is? 16. 20 minus 16. 20 minus 16. 4. 20 minus 16. 4. 4 ones. Okay. In this octet, you will get a 4 ones. Now tell me the full value. What is the value of this one? 240.
240.
Okay. So this is the subnet mask from here. Okay. There are a lot of calculations are there, guys, but it's already 6 o'clock. Actually, my planning is different, and what I done is different. So
Yes, it's getting too much confusing, sir. By repeating this, we get too much confusion for that.
yeah, yes, that's right. Actually, we need a certain time, at least 2 days,
Yeah.
and you have to practice because I am telling, and of course you are giving answers also. That is also great. At least by online you are getting minimum response. That is one happy thing. Okay, but you have to continuously practice both discussion like that, and compulsory. If your interviewer said like definitely questions from the subnetting, then I can trust more on it. Okay, otherwise I'm not getting much challenging in this one. Okay, like that. So that's why I'm confusing in that point, like whether I have to go for it or not also. That much big. So don't worry. So subnetting is actually a very beautiful concept. What I will do, there is a subnetting concept is there. Subnetting. Okay. My point is, guys, I will take this subnetting class now and I will finish in the half an hour maximum. Point is, you got the point? Good. You don't get the point, keep it. Maybe you can try after some time. Okay. So 1 or 2 examples also I will tell. Then we will finish it. So we don't touch it tomorrow. It's a little, as you said, that is a correct one. So you'll get a little confusion in it. Okay.
Tomorrow we can go to another topic now, sir.
Better we'll go to another fresh topic. NAT-PAT is still pending. So we'll go to the NAT-PAT. Any pending topics are there. So we'll see. And services, DHCP, DNS, Active Directory, these things also we'll discuss tomorrow. Okay.
Yeah, okay, sir.
Okay. This part we will complete today and take a relax for 5 minutes. Okay.